So let's move on to chapter 4, which is inductance. Okay, inductance and capacitance are almost similar, but the difference is capacitance, it will store the electrical energy in between the plates. Okay, it will store electrical energy in between the metal plates, which is positive and negative. But for inductance, it won't store, but it will produce electrical energy in the magnetic field. So I'll show you how. So first of all, inductor is a device to store electrical energy in magnetic field. Inductor is like a aluminum coil or copper coil wounded on a magnet like this. Okay. So if you pass one current through this coil or the wire, magnetic field will be generated inside this one and it will produce electrical energy in that magnetic field. They won't ask you how the electrical energy is produced or what is the theory. They will ask only which is the device to store electrical energy in magnetic field. So please don't write capacitance, it's inductor. The one who will store electrical energy in the magnetic field is inductor. The one who will store electrical energy in the metal plates is capacitor. Okay, I hope it's clear. Let's move on to the type 1 question, which is a common question in end of the term exam. You can find the same question in end of the term. Every year this question is repeating. Okay, the symbol for the inductance is this one. Okay, this is a standard symbol. It's like a coil wounded like this, 4 wounds. Okay, so as you studied, there are 2 types of capacitor, fixed and variable. There are 4 types of inductors. Okay, if it is just the symbol like this, it's fixed capacitor. Okay, sorry, not fixed, air core inductor. Air core means the medium is air. Okay, so if it is just a symbol like this with the coil wounded, it's fixed air core inductor. If it is a coil with strong 2 lines on the top, it's iron core. It's very strong. So it's iron core inductor. Okay. If the lines are dotted, which is not strong, it's called ferrite core inductor. So you have to memorize these words. Okay, I repeat, if it is dotted, it's ferrite. If it is strong lines, it's iron. If it is with an arrow like a capacitor, it's variable air core inductor. So if whatever the symbol, if it has an arrow in the middle, it's variable. Okay. So the first one is fixed. The 2 strong lines indicate it's iron core inductor. The dotted lines indicate it's ferrite core inductor, and the arrow line indicates it's variable inductor. So these 4 things you have to memorize the names. Don't confuse yourself. The symbol method is the one without anything is fixed one. The one with the strong lines is iron because iron is very strong. One with the dotted lines is ferrite, which is a new word for you. Okay. The one with the arrow is always variable. Let's move on to type 2 questions, which is a similar one of in the capacitive chapter. Okay. So I will read it for you. For the current and voltage waveforms of AC inductive circuit, fill the space with the correct word. So in this type of questions, they will give you the words to fill: voltage waveform, current waveform, Vmax. You have to take this one and keep it in right boxes. Here I wrote the answers, but in question paper there won't be this red ones. Okay. So normally most of the students will confuse like uh, which which wave will be for which wave will be the starting wave for capacitor and which wave will be the starting wave for inductor. If you remember, for capacitance the starting violet color wave was from here and it was current waveform, I told you. Okay, and current was leading the voltage, which means current was in front of the voltage waveform in capacitance. But in inductance, it's opposite. The voltage waveform is the violet one and it will lead the current with 90 degrees. So this is the voltage waveform, the first wave. Second wave is current waveform. which, and the voltage and the current has a 90-degree difference. Okay, so you can write the first waveform here as voltage waveform, second as current, and you know that the topmost point of the first is Vmax, topmost point of the current waveform is Imax, which is maximum current and maximum voltage. I hope it's clear. So don't confuse. For capacitive circuit, current is the first waveform. For inductive circuit, voltage is the first waveform. So don't study like violet color is for current and blue or green is for voltage. No, it's not like that. The first wave starting for capacitive is current, and the first wave starting from this line for inductive is the voltage. Okay. Now moving on to type 3 question. This is not a common question. Maybe they will ask, maybe they won't. Okay. It's something called Fleming's right hand rule. According to Fleming, if you keep your right hand like this, okay, your thumb, direction of your thumb is upward direction, right? So it will indicate the direction of motion. Okay, and the middle finger direction will shows the motion, the direction of magnetic field, and the last finger, forefinger, will indicate the direction of current. So just memorize this one. The thumb is for motion, middle is for magnetic field, and the last one is for current. Okay, this is probably it will ask, maybe it will be in the answer the following. Okay, now moving on to type 4 question. This is again similar to the capacitance. List the 4 factors affecting inductance of a coil. You can expect this type of question from either capacitance or inductance, because this is a repeated question. Either the question will be list the factors affecting capacitance or list the factors affecting inductance. For that you have to keep in mind the equation for inductance and capacitance. Inductance L is N square mu A divided by L, where N is the number of turns. I told you inductor is having a coil with turns like this. How many turns? 1, 2, 3, 4, 5, 6, 6 turns, right? So N indicates the number of turns. Okay, mu will be given in the question paper. Like for capacitance, there was something called epsilon 0. You flip the 3 and you will put 0 down, right? Like that, for inductance, the core material is mu. A is the area as same, but it's coil area. For capacitance, the A was for plate area, metal plate area, right? Here for inductance, it's coil, so coil area, and L is coil length. Okay, so the 4 factors which will affect the inductance are: first one N, which is the number of turns in the coil; second one is mu, which is core material. Okay, core material means you studied 4 types of material, right? Fixed, iron, ferrite, and variable. So that is core material, means the name of that one. It can be either iron, it can be ferrite or something. Okay, A is coil area and L is coil length. So you should write this equation first and write the 4 things which will affect inductance. Type 5 is again similar to capacitance. Remember, I told you there is a resistance similar to resistance. We had capacitive reactance, right? Like that, we have inductive reactance, which is denoted by XL since it's for inductor. And the equation is 2 pi FL. For capacitance XC, it was 1 divided by 2 pi FC, right? So flip that one and replace C with L. So now XL is inductive reactance is 2 pi FL, where F is the frequency in Hertz, L is the inductance in Henry, H. This is very important. The unit of inductance is Henry, Henry, and symbol is H. The unit of capacitance is Farad and the symbol is F. Okay, so this equation is very important. Now, One question, what is the inductive reactance of 0.15 Henry coil at 60 Hertz? So just write the equation. XL is 2 pi FL, F is given 60, L is given 0.15 Henry, L is given 0.15 Henry. Just substitute. Write the equation first, 1 mark. XL, substitute the value 2. Pi will be given in the question, okay, 3.14. Or if just study pi, the value of pi is 3.14. Multiply F is 60 Hertz into L is 0.15. Just substitute. If you don't know how to multiply, just keep space or dash here and put the unit ohm, because inductive reactance is ohm. I repeat, inductance unit is Henry and inductive reactance unit is ohm. Okay. Type 6 question, which is again similar to the type 5, which has the same equation and the Ohm's law for inductance, I equal to V by XL. So let's see the question. The inductor shown in the figure, okay, no need, has an inductance of 0.h Henry. So I will put L as 0.h Henry. It's connected to a 120 volt, which is V, 60 Hertz, which is F. Please round the values in the question paper, which will make easier for you. Okay, how much current will, so you have to find the current, how much current will flow through the circuit. Okay, first one, for finding Ohm's law current, you have to find V. V is given in the question 120, and you have to find XL, which is inductive reactance. So XL is 2 pi FL. Substitute 2 pi is 3.14. F is given in the question 60 Hertz and L given 0.8. So find the value and write the other equation for current, I equal to V by XL. Substitute the values, and if you don't want to divide, okay, just keep the answer space and just put the unit ampere. Unit of current is ampere. Okay, I hope it's clear.